To answer this question, we have to keep in mind what the octet rule states. The octet rule will help us understand why these elements are trying to become ions in the first place. The octet rule says that atoms are most stable when they have a full octet of 8 valent electrons. Therefore, we need to look at each of these elements, see how many valent electrons they have to begin with, and then see how it's going to be easiest to make an ion that has 8 valence electrons. So it's best to do this by example. So I've got a periodic table here. And so we want to find the charge of bromine, rubidium, and oxygen. So first, let's find these guys on the periodic table. Bromine is down here in group 7, right there. Rubidium is all the way over here, and I better use blue to box him in. Rubidium's down here. He's in group 1. And by the way, the group is which column it is in on the periodic table. So this is group 1A, 2A. Bromine's over here in group 7A. And I'm using these Roman numerals to distinguish that. And oxygen, finally, is up here in group 6A. Okay, so what group an element is in tells us how many valence electrons it starts with. So looking at bromine, bromine is here in group 7A. That means bromine has 7 valence electrons. We can draw the Lewis dot structure for bromine like this. 1, 2, 3, 4, 5, 6, 7. Sorry, that's a little askew there. So bromine already has 7 valence electrons. Now the octet rule says we need to have 8. It'll be most stable with 8. That means that we just need to add 1 more electron. Boom. That was a very easy way. It was easier for bromine to gain an electron than to lose an electron, because to lose electrons to get to a full octet, we'd have to get rid of all of those outer electrons, go from 7 down to 0, so that we'd have a full energy level in the layer beneath. And that would take a lot of work. Bromine can't really do that. Plus, there's an idea about electronegativity and electron affinity, where bromine is more likely to gain electrons than lose them because it's a nonmetal. But all that is to say that bromine can easily gain 1 electron, and since it has 1 extra electron now, that means bromine is going to have a -1 charge on its ion because it got an extra electron. And remember that electrons are negatively charged. So before, it was neutral, same number of protons and electrons. Positive and negative canceled. But with 1 extra negative charge, now my overall charge is -1 on the bromide ion. Okay, so that was bromide. And now we can kind of go a little quicker through the last 2. I've made a terrible mistake and accidentally erased everything I worked so hard to build. Okay, so I'm not going to be able to just erase that. Oh, that's going to be hard. Ugh. You get to watch me do this live. Oh, okay, we're going to ignore that now. So bromine is -1. Now let's look at rubidium. Rubidium's over here in group 1. That means it's got 1 valence electron. I'll use blue for rubidium, and boom. Rubidium has 1 valence electron. And rubidium would like to have 8 valence electrons. It would be hard for rubidium to get 7 more valence electrons. Plus, we'd have to fill in a whole D sublevel for all of these elements that are in between it and its noble gas configuration. What would be really easy, though, is if we just lost this 1 electron that we have. If we give it away, that means we're going to have a full octet of 8 electrons in the energy level beneath. And that's a really easy way to get to that stable electron configuration. So instead of gaining electrons, we're just going to lose that electron. And that gives us a +1 charge because we were neutral, but now we have 1 less electron, which means we're going to have more protons than electrons, giving it a +1 charge. And finally, oxygen is going to be very similar to bromine. So oxygen has 6 valence electrons already. I wrote those in green there. And to get to a full octet, like bromine, since it's a nonmetal, it'll be easier for it to gain electrons than lose them. And so to get to that full octet, all we need is 2 extra electrons. Boom, boom. And the 2 extra negative electrons means oxygen or oxide will have a -2 charge as its ion.